Okay, now let us continue for the Bn. Here we have Bn equals to 1 over 2. We have negative cos n pi over 2t divided by n pi over 2 with the boundary 0 to 2 here. Okay, so based on this, then we can continue that the Bn now equals to negative half. Okay, because it is negative, so we have cos n pi over 2 multiply with 2 because the t is 2 here, and then minus cos 0, okay, multiply with n pi over 2 which is also 0, and we have n pi over 2 here, right? Okay, so based on this we have negative half 2 over n pi, and we only have cos n pi minus 1 because the cos 1 equals to 1. So based on this, we have here 1, okay, and returns to, if this is negative, so I can now multiply with minus 1 here, so that I have 1 over n pi 1 minus cos n pi. Okay, so I hope you can follow this for now. Alright, after this, since we know that Bn equals to 1 over n pi multiply with 1 minus cos n pi, the first thing is what we need to understand is all these are defined for n equals to 1, 2, 3, 4, so on and so forth. So we can start with the B1 when n equals to 1. So we have 1 over pi, 1 minus cos, here we have 1 minus cos pi. So what is the value of cos pi? It is negative 1, right? Okay, so for this B1 we have equals to 1. Okay, 1 minus 1 equals to 1 divided by pi. Now, let's say if we want to continue with B2, then we have 1 over 2 pi. Okay, 1 over 2 pi multiply with 1 minus cos 2 pi. Okay, so what we have here, cos 2 pi equals to 1. So 1 minus 1 returns to 0. So we have here equals to 0. And if we continue with n equals to 3, we will get 1 over 3 pi. And then if we use the B4, we will get 0. And it will go to a conclusion that if n is odd, we will have the value of Bn equals to 2 over n pi multiplied with 1. Okay, sorry. If we have this one, n equals to odd number, then we will have this value of 2 over n pi. But if the n is even, we will get a value of n equals to 0. Okay, so I hope you can try now with B1, B3, B5, and for this one, if we try with B2, B4, and B6, we always got this one. Okay, and with that conclusion, we can now write that Bn equals to 0 if the n even, and the Bn equals to 2 over n pi when the n is odd. Okay, so with this definition, I can now get the value of the Bn. I can represent the value of Bn like this. Okay, so we already know the A naught, we already know the AN, and we already know the BN. So now we want to plug in all these values into the series expansion, Fourier series expansion of the FT. So using the formula that FT equals to A naught over 2 plus summation of AN cos n omega t for n starts from 1 to infinite plus another summation of Bn sin n omega t for n starts from 1 to infinite here. Then we can now write that before this we know that the A naught is 1 and the AN is 0, while the BN is given by two conditions where it is 0 when n even and it is 2 over n pi when n odd. Okay, so we can now write like this: 1 over 2 plus 0, so no need to consider this, so plus the summation of Bn. So how can we write in this case? Okay, I can now write the non-zero value, which is 2 over n pi multiply with sine n pi over 2t here, but I need to mention here that instead of 1 equals to 1, n equals to 1 to infinite, the n must be odd. Okay, so with this mentioned in the equation, we know that this sine n pi t over 2 multiplied with 2n pi is only valid for n odd. Okay, so overall, this is the answer for our Fourier series expansion for this example.